Hi guys, back with me again, Adi Kurniawan Yusuf. In this video, we would like to discuss how to conduct validity and reliability tests in SPSS. Before that, I want to explain to you two common variable types. The first one is latent variable and the second one is manifest variable. Latent variable is a variable that cannot be directly measured and requires indicator as proxy. So you cannot directly measure this variable, but you need indicators to measure this variable. For example, you want to analyze customer experience. It is difficult for you to directly measure customer experience. You will use several indicators of customer experience to measure customer experience. For example, service interaction, physical environment, virtual environment. That is latent variable. And latent variables is drawn using ellipse symbol. The opposite of latent variable is manifest variable. Manifest variable is a variable that can be directly measured by the researcher. For example, you want to analyze the profitability of the company, you can directly use the data of return on asset or return on equity. Or you want to analyze the score of statistics class after training. The score is directly available. You don't need indicator in this case. For manifest variable, it is drawn using rectangle. Then, what is the relation between the type of the variable and validity and reliability? The problem is that when you want to measure latent variable using several indicators, usually you will distribute the questionnaire or you will try to gather the primary data. If you gather the primary data, you have to make sure that the data is valid and reliable. Therefore, we need validity and reliability tests. So, validity and reliability tests have to be conducted in the primary data. And the primary data is usually used to measure the latent variables. However, if you use the secondary data, for example the financial data, you don't need to test validity and reliability as long as the source is valid. For example, the data is gathered from the Statistic Bureau or Indonesia Stock Exchange. Now let's discuss what is validity, what is reliability. Validity is the extent to which the instruments that are used in the experiment measure exactly what you want them to measure. So, for example, you want to analyze customer experience, the instrument is considered valid if that instrument really measures about customer experience. How to know conducting validity tests? How about reliability? Reliability is the extent to which the outcomes are consistent when the experiment is repeated more than once. It talks about consistency. For example, the questionnaire is distributed twice and the answer of the respondent is mostly consistent, it is reliable. This is the comparison diagram about validity and reliability. Now let's try to test the validity and reliability in SPSS. So I have this data. There are three variables, the X1, X2, and also Y1. There are 6 indicators to measure X1. There are 8 indicators to measure X2, and there are 3 indicators to measure Y1. Before you analyze the validity and reliability, you have to find the total score for each variable. Okay? So for the first variable, X1, I found the total score, so X1 dot tot. So let's find the sum of total value. This one. Close. Okay, the total is 24. Okay, just drop it down and you will find the total for each row in the X1. The next one is X2. You can find X2 dot, just sum it all. Okay, and then drop it down. Do the same thing for Y1. After you find the total of each row, then you can enter the data in the SPSS. So I open SPSS. I will import the data directly to make it faster. The data has been imported like this. After you have imported the data will appear in the data view. You can change the type of the measurement into scale or ordinal. It won't affect the result of the validity or reliability. This is the steps to conduct the validity test. You have to test each variable. One more time, you have to test each variable. So the first one we will test x1, the second one we will test x2, the third one we will test y1. The step will be analyze, correlate, bivariate. Analyze, correlate, bivariate. Okay? And then move x1.1 up to x1.6 with the x1 total to the right. Okay? x1.1, x1.2 up to x1 total to the right, since we have to test each variable. Then press OK. This is the result of the validity test. Actually, to know whether it is valid or not, we can see from the Pearson correlation and also seek-to-tilt. For the Pearson correlation, you have to compare the result of the Pearson correlation with the R table. It is like when you compare the C table and C calculation, T table and T calculation, F table and F calculation. However, to make you easier, just compare from the seek-to-tilt. If the seek-to-tilt is less than alpha, it is valid. If the seek-to-tilt is more than alpha, it is not valid. Let's set the significance level or the alpha is 5%. So if the seek-to-tilt is less than 5%, it is valid. We can see here x1.1, the seek-to-tilt is 0.109. It is larger than alpha. So x1.1 is invalid or not valid. x1.2, 0.000, this is valid since it is less than alpha. x1.3, this is valid. x1.4, valid. x1.5, valid. x1.6, valid. We do not need to see x1 total. So, for the x1 indicators, x1.1 is not valid while the rest are valid. Now, what should we do if there is invalid indicators? There are several options. The first option is that we can fix the question in the questionnaire and then we redistribute again the questionnaire. Or the other option is that we can add our respondents and see whether that indicator will be valid or not. Or the last one, if you have a lot of indicators, you can directly drop invalid indicators or drop invalid question. Since we have a lot of indicators here, there are 6 indicators. If we drop one question or indicator only, we still have 5 indicators and it is enough. So in this session, we decide to drop the invalid question or indicators. Actually, there is no fixed minimum requirement of indicators used, but usually the most common number of indicators used to represent a latent variable is 3. Now let's try to analyze the validity for x2. Analyze, correlate, bivariate again. Now move x2.1 up to total. Here we can see that x2.1 is less than 5%, it is valid. x2.2 it is valid. x2.3 valid. x2.4, yes, it is still valid. x2.5 valid. x2.6 valid. x2.7 valid. And x2.8 is valid. It means all indicators for x2 are valid. Now let's try to analyze for y1. Analyze, correlate, bivariate. Move it to the left first for the x2 and then move the y1 into the right. Okay. We also see here that y1.1 up to y1.3, the result of the seek-to-tilt is 0.00. It means all indicators are valid. So the conclusion of our validity test that only x1.1 is invalid and we decide to drop that indicators, while the rest of the indicators are valid. After you check the validity, then you need to check the reliability. You need to check the reliability by only considering the valid indicators. One more time, you need to check reliability by only considering the valid indicators. So for the x1, we need to drop x1.1 since it is not valid. we cannot include x1.1 in reliability test. This is the step to conduct reliability test. Analyze, scale, reliability analysis. Again, for reliability analysis, you have to analyze it per variable. Okay, we have to analyze x1, so you can move x1.1 up to x1.6 to the right. You don't need to include x1 point dot. Okay, the total, you don't need to input the x1 total or the total score of all the variables to the right. However, since x1.1 is invalid, don't include x1.1. Just move x1.2 up to x1.6 to the right. You can see here the model is alpha. It means the reliability analysis we use is analyzing Cronbach alpha. So, okay. We can see here the Cronbach alpha is 0.696. What is the interpretation? If the Cronbach alpha is around 0.6 up to 0.8, it is acceptable. While if it is higher than 0.8, it is very acceptable or high acceptable or very reliable. So the conclusion is that if it is more than 0.6, it is reliable. There are other sources that mention that actually the minimum standard is 0.7. However, actually we can also use the standard of 0.6. Next, let's test the reliability for X2. Analyze, scale, reliability analysis. Move x2.1 up to x2.8 since all of them are valid. Okay. We can see here for x2 the Cronbach alpha is 0.689. It is reliable. The next one is Y. Analyze, scale, reliability analysis. Move y1.1 up to y1.3 to the right. Okay. We can see here also the Cronbach alpha is 0.673 and it is reliable. My question is that, what happens if the variable is not reliable? The first thing we can do is that fixing the question or indicator that is not reliable. The second one, we just drop the question or indicator that is not reliable. The question is that, how can we know which question or indicator should be deleted? So guys, for example, this is not reliable. In the reliability test, actually you can analyze which indicator or question you should delete to achieve higher reliability score. Let's try for X2. Analyze, scale, reliability analysis. We go to X2.1 up to X2.8. Move it. Statistic, tick scale if item deleted. Previously, you know that the reliability score for X2 is around 0.6 something, right? However, if you delete X2.5, the Cronbach alpha can be higher. It becomes 0.701. But in this case, we don't need to delete it because it has been reliable. Do you get the idea, right?